Okay, so here's what I want to say about the quiz. The median grade was, I think, 75.5. And again, that means that if we lined everybody up from highest down to the lowest, person right smack dab in the middle got a 75.5. The bad news is exponents are really hard. Radicals are really hard. And so some of you guys had a big drop in your grade going into this quiz. The good news is you'll have an opportunity to kind of make up for it on our second test, which is near the end of the semester, where you will see problems similar to the ones on this quest. The other thing that I'll say about the exponents and radicals is that some people are doing things that show that they're trying to just memorize rules without having any understanding of what's going on. And so I'll just give you a small example here. If I said simplify the square root of 50, so here's what I'm envisioning is that you write that as 25 times 2, and then you split this thing up into two radicals because that's one nice property about radicals, and then the square root of 25 is just 5. And so this is our simplified answer, 5 times the square root of 2. And I tried to write it out in all the detail when we were first doing these kinds of problems. But some people I feel like are just trying to memorize but don't know what's going on. And so they do this. It's okay, square root of 50. They don't understand clearly this whole idea of breaking a radical up when it's multiplied. And they'll say, let's see, 50 is 25 times 2. They won't write anything down, just in their heads. 50 is 25 times 2. 25 is a 5. And then the 2 comes outside with no sense of what's going on. Just they understand the numbers 5 and 2 are important, but by swapping them show me that really don't have any idea that we're really just splitting up a radical with a multiplication sign in the middle. And so I will encourage you, if you are just trying to memorize rules, don't. There are too many of them to just memorize. Like you really have to understand what's going on, what makes these things tick. So as you study for upcoming quests and tests, I encourage you not to just flat memorize. The results don't end up well. Okay, so we're here on page 41. One quick announcement not related to class. So there are 2 information sessions happening this week where other colleges come onto campus and try to encourage you to transfer to their 4-year schools. Both of them have to do with pharmacy schools. So if you have any interest in going to a school with a pharmacy major or pharmacy discipline, let me know and I will show you the details on this document. All right, it's Albany and then Western New England University, Thursday and Saturday are the 2 dates, but I'll show details if you want to see them. But if you have any interest in a pharmacy program, let me know right after class. Okay, so here's our calendar. We just took our 3rd quest. There are 5 altogether, which leaves 2 more quests, 1 more test, and the final exam. That's all that we have left in terms of assessments in class. Today we're going to talk about solving quadratic equations by factoring, which will kind of remind us of the factoring that we've done over the previous 2 classes that wasn't on the quest. And that begins here on page 41. So let's start here in the middle of page 41, and we'll begin with number 1. Can we go to Alan? Okay, so let's just look at a quick example. If one of you guys got me sick, it's like a -50 on the quest. Okay, so there's an example of a quadratic equation, y equals 3x squared minus 2x plus 5. The defining characteristic is that the highest power on the x is a 2. And so we're going to be working a lot with quadratic equations in the coming classes. And again, we're looking for the highest power on the x to be 2. Why does it say that a can't be 0? Well, how much is a in this case? Remember, a is always going to be the number touching the x squared. So how much is a? It's 3. And b is always the number touching the x. How much is b? It's -2, including that negative sign, right? And then c is the number sitting there at the end without any x's. That's a +5, okay? So hopefully with some practice, we can just peel off the a, b, and c, but we're always going to use those same letters, a, b, and c. And what would it mean if the a were equal to 0? Well, if the a was 0, then this part right here would be a 0. And if it were a 0x squared, then that term isn't really there. And so this is really just a bx plus c, for example, negative 2x plus 5. That's a line, and that's a linear equation. And we already have studied linear equations, and they don't really have a whole heck of a lot to do with the quadratic equations we're about to study. And so our a not equal to 0 is just our way of saying there's really an x squared term there, not just like superficially one with a 0 in the front, so it's not actually there. Okay, let's go to Alexa for 2. Okay, so let's take a look first at the table. Let's just pick this one right. Let's pick this one right here, actually. So this first column is x. If you plug x equals 2 into that x right there, then copying everything else around it gives me that. Yes? Substitute the 2 for x. So let's do that calculation. 2 squared is 4, times another 2 is 8, subtract 5 is 3. Everybody comfortable with that? So if x is 2, then what? Y is 3. Yes? And so that's what this says right here. Second column is the y. And then putting it together as an ordered pair, x, y, 2, 3. Okay, go to the graph over here and plot the point 2, 3. And hopefully you see it's actually already there. In fact, I've graphed all the points that are on the graph of that equation, but 2, 3 is right there. And I made the rest of the table. We're not going to go through it all. But if you just plot a lot of points, like the ones in the table, let's see, so we got that one up there, and then this one here, here, there, and there, and that one there. So there are 7 points that I plotted, and then I used GeoGebra to really graph the whole thing really nicely, but we get that, which looks radically different from all of the straight lines we've graphed this semester, okay? All right, so let's start answering some questions about the graph of this equation. What is the y-intercept? So let's look at the graph. Remember, the y-intercept is the place where the graph hits the y-axis. How much is it? Looks like it's around -5. The y-intercept is this guy right down here where the graph hits the y-axis. Looks like it's approximately -5. Is there a way to know what it is exactly? Yeah. If you wanted to find the y-intercept, what would you do with the equation? You let x equal 0. You guys remember, to find an intercept, you let the other variable be 0. So to find the y-intercept, you let x equal 0. And so if you put a 0 right there for x, then what do you get? You get -5 is the y. So it's exactly -5. And in fact, we can see that here in the table. When x is 0, y is -5. So the y-intercept, no matter how you slice it, is -5, or if you want to put an ordered pair, 0, -5. Okay, part B. Oh yeah, Boo. Okay, so Boo, I think is referencing something for this equation, the mx plus b. And what is that b called? That's the y-intercept. So if we're looking at that kind of equation, a line, then absolutely the number sitting by itself there at the end is the y-intercept. So we're having to develop new formulas here, but is Boo's observation correct? Is the number sitting by itself in that equation the y-intercept? It is. So I don't want to call it b because it's not the same letters. Our new equations are going to have these letters. But yes, if whatever number is there sitting by itself in a quadratic is still the y-intercept. So you're right, we don't need to technically plug in the 0, it's just sitting there. Very good. Okay, part B. How many points have a y value of 13? Okay, let's go up here to the graph and figure out how many points have a y value of 13. So if I go to y equals 13, which is near the top of the graph, maybe right around here, and then I look left and right, how many points do you find that are on the curve? You see the 2? So we can go out this way and find one, we can go out that way and find another one. So we see 2 points. And then it says write the coordinates of the points that have a y value of 13. Okay, well, the good news is I labeled these ones for you. So the coordinates are -3, 13 and +3, 13. Okay, part D, from the graph and the table, we can see the solutions to the equation 13 equals 2x squared minus 5 are, and then there's 2 blanks here. Okay, let's pause because there's a lot going on in that question. All right, looking at the right-hand side of this equation, I want us to first recognize that it's exactly the same as the right-hand side of the thing that we graphed, right? 2x squared minus 5, exactly the same in both. And so according to what's circled up here in black, 2x squared minus 5 is something I am calling y. So then down here, the same 2x squared minus 5, I guess what we're saying is that the 13 is the y. We see that? It's kind of like a substitution thing, but it's really just like in your mind matching things up and saying, oh, the right-hand sides are the same, so I guess we're really saying the left-hand sides are the same. That 13 really represents a y. And so if I asked you to find places on the graph, the curve, where y is equal to 13, well, you would do something like we just drew up here. I'm going to erase it and do it like I did in 095 with some of you. If I wanted you to solve this equation, you'd go to the 13, you'd go to the right, and then what would you do? Would you solve the equation from that point? What's that? We're trying to solve the equation just by looking at the graph. So where would I go? I go straight down. And we land on the number x equals 3. See that? The 3 is the value on the x-axis right at the bottom of that arrow. So I went to 13 because that was what the y value was. And then I have to go left and right. We're going to go left in a second. But I went to the right until I hit the curve. I landed on this blue point right up here. And then I went straight down. And I get to x equals 3. And that's one of the solutions of the equation. You guys remember doing this in 095 if you had 095? You can draw this horizontal thing either left or right, and then you hit the curve, and then you go down in this case. Sometimes you have to go up to figure out what the value of x is. What's the other solution to the equation? X equals -3. I don't want that to be a mystery. Let's make sure it works. Like the picture says something, but let's make sure this agrees with what the equation says. If you plug x equals 3 in, 3 squared, 9 times 2, 18 minus 5, 13 works. Okay? And when you do that -3, you're going to get the same 9. So we'll get the same 13. Okay, so the point of this is that for the first time this semester, it's here right after part D, as we can see, when you solve a quadratic equation, you can get more than one solution. For the first time this semester, we have an equation, this equation, which had 2 solutions, x equals 3 and x equals -3. That's a really different thing than all of the equations we've seen this semester. You can play with that equation and solve it, and you will get exactly one answer. I don't think we've ever had one where there were 2 different solutions to an equation. But now for the first time, with this whole quadratic equation business, it is very common to have 2 solutions to an equation. Okay, let's try number 3, and we'll go over here to Brandon. Keep going. Okay, so we want to set the whole thing equal to 0. That's going to be a key, and we're going to do that a bunch of times today. We'll come back to that. Let's see if we can just practice putting things into standard form on the next page. The goal is to manipulate the equation so that one side is equal to 0. So in the first equation, how do I move that negative 8x over so that I have just 0? Add it. So let's add 8x to both sides. And when we add 8x to both sides, I'm going to write this guy in standard form, which means the x squared term is first, then the x term is second, and then the number by itself is last. What remains on the right-hand side? 0. So that equation is in standard form. Standard form, we're just defining it right now. It means two things. X squared is first, x is in the middle, constant term is at the end, and one side is what? 0. That's key. You'll see why in just a minute. Okay, let's try part B. So let's move the 4x over to the left-hand side. How do we do that? Subtract 4x from both sides. So I get x squared minus 4x equals what? 0. That's it. And then same thing for part C. What do we do to both sides to get a 0? Subtract that 4 from both sides. We get x squared minus 4 equals 0. All three of these are in standard form now. Questions on standard form? Okay. So number 4, let's go to Alex. Okay, let's skip 5 and try number 6 just to put that idea into play. So we're trying to solve this equation, 2x squared equals 4x. Okay, so the first step apparently is to get it in standard form, which means we need a 0 on the one side. So let's go ahead and subtract 4x from both sides. So we get 2x squared minus 4x equals 0. Okay, so here's the new thing. Remember all that factoring stuff we did the last 2 classes? This is the moment right here which makes it pay off. Here's why we factored. We're going to factor this equation right here. Now this guy, a lot of the quadratics that we factored, don't write this, but a lot of the quadratics we factored ended up looking like this, right? 2 parentheses, x and x, and then we had to fill in some stuff. This guy's a little bit different because it doesn't have all 3 terms. Normally there'd be a constant sitting at the end here with no x's touching it. If there isn't, it turns out there's a really simple kind of factoring. And in fact, it's the first kind of factoring I look for every problem I'm trying to factor, is I look to see if there's anything I can pull out of all the terms. So what's the biggest number you can pull out of the 2x squared and the 4x? Is it 2? And then are there x's in both terms? Yes. So what can we pull out as well? Single x. 2x is the right thing to pull out. And then we have parentheses here. And the goal is to figure out what must have been in those parentheses. Yeah, and so I'm going to put a minus sign in the middle, just copying that minus sign so we can really separate the 2 things we're after. So there was a miracle way and there was a procedure way. Either way, can somebody tell me what goes in that first blank? 2x? I think it's just x, because if you do the 2x on the outside times the x on the inside, you get exactly 2x squared, which is right. And then I'm supposed to take 2x times the other blank and get 4x. So it must be a plane 2. And it's still equal to 0. Don't forget to keep writing. If it's an equation at the start, it's going to be an equation every step along the way. Okay, so it's factored. And now we get to the new piece for today. I'm gonna highlight the 2x, that's one thing, and then separately I'll highlight the x minus 2, that's another thing. But ultimately what symbol is between those two highlighted things? Is a multiplication. So forget the fact that these two highlighted things are complicated. All we're doing is multiplying two numbers together, even though the numbers look quite complicated. But we're multiplying two numbers together, okay? And we get 0. What's the only kind of numbers you can multiply together and get 0? They both have to be 0? One of them has to be 0, right? The only way you can multiply two numbers together and get 0 as the answer is if one of them is 0. For example, is 8 times 7 equal to 0? Definitely not. 115 times 42? I don't know what it is, but it isn't 0, right? But 0 times 17, that's easy. That's 0. And 53 times 0, that's easy. That's 0. The only way to multiply two numbers together to get 0 is if one of them was equal to 0. So what we are saying here is that we have multiplied two numbers together and gotten 0. And the only way that can happen is if one of these highlighted things was equal to 0. And so we're going to write down two separate equations. I'm going to copy the 2x here, copy the x minus 2 over here. I'm going to highlight them again, same as they were. And what we are saying is that one of these two things has to be 0, and so we're going to write down two brand new equations, making each of them equal to 0. Everybody see what we just did? Yeah, we did take off the parentheses. You can keep them if you want to. But this is the most important step for today. It's the new step for today, is that after you've factored this kind of thing, because we worked hard to get a 0 there, it wasn't 0 before, but we had to get a 0 there so we can use this really important property of numbers, that if you multiply two numbers and you get 0, one of them had to be 0. Is that true for other numbers? Like if I told you that x times y is equal to 8, does one of those numbers have to be 8? No, what could the numbers be? 2 and 4, right? It doesn't work unless the magic thing on the right-hand side is 0. You can't just say one of these numbers is equal to 8. But if it's a 0 over there, you can say one of the numbers is 0. So we've got two easier equations to solve. We'll solve the first one by doing what to both sides? Divide by 2. And so 0 divided by 2 is our answer. How much is 0 divided by 2? 0. That's good. That's one answer. Second equation, what do we do to both sides? Add 2. So x equals 2. So those are our two solutions. X equals 0 and x equals 2. I think so. I hope so, because this stuff is gold that I'm saying here. Yes, boo. Yes. If the equation had an 8 on the right-hand side, so I'm going to cross this off and make it an 8. We can't do, there's no point in factoring. If this over here is 8, factoring is useless, because just because you multiply two numbers and get 8 doesn't tell you anything, doesn't tell you one of the numbers is 8. But if it was an 8 over there, then we haven't finished putting it in standard form. What number do we need over there? We need a 0. And so how would we get that 8 over to the left-hand side? As we'd subtract 8. And so you'd end up with this equation. Subtract the 8 from both sides. You have to make it a 0. That's the first thing. So don't bother factoring until you've made it a 0. Megan, can you put that away? So you'll never end up in a situation where it's not 0, because that's the very first thing you do, is make it 0. That make sense? Yes, because once you factor it, you set each of the two things equal to 0. So the basic pattern, I think Boo is after it here, is that, let's see here, get rid of that, there, is that we make one side equal to 0, we factor, we split it up, setting each piece equal to 0, and then you solve the two easier pieces. That's the process. Okay, So before we jump into the group work, let me just make one more announcement. I don't know if I've made this announcement in this class, but I'm going to do something strange while I do it. I'm going to stare at that back wall while I make this announcement so nobody thinks that I'm talking specifically to them. But this coming Friday is the last day to withdraw from any class, this one or another. So if you are thinking about withdrawing from a class, it has to happen this week, by Friday at the end of the day. If you want my opinion on your standing in this class right now, just see me after class or some other time this week, but there's some time sensitivity if you are considering withdrawing. Questions on that? Okay. Sometimes I'll make that announcement and somebody will think I'm targeting them because I make eye contact with them. What is Ian saying? Okay, so the process that we just listed right there for solving quadratic equations, it's this 4 steps. Standard form, one side to 0, factor, set each factor equal to 0, and then solve each resulting simpler equation, right? 4-step process. Looking at the first 4 equations, you guys are going to do group work and you'll have plenty of time to get started on the homework here. What do you notice about the standard form piece for the first 4? Yeah, it's already set equal to 0. And then the next step is factoring. What do you notice about the first 4? Remember, factored means it looks like something times something. They are already factored. The first 4 are much easier than the rest of them because the first 4 are already factored, as opposed to like part E, where it's not factored. Remember, factored means something times something. So first 4 are going to be pretty quick, and then starting in step E, you'll have to do all 4 of the steps. Okay, I'll put the flags out. Raise the flag if I can help.